Hello, welcome back to Learn Physics. Today also we are continuing with the kinematics revision only, and that is third part of the revision, and because first, second and third it's over, and now it is third part is going on. Okay, so in between I want to say one thing, and here almost all the portions I'll try to finish, because now in most of the schools 12th exams over and 10th exam over, right? Public exam for CBSE 12th and CBSE 10th today it got over, and now only state syllabus 11th standard is pending, I guess, for the public exam. So I have some 11th standard questions, previous year questions with me. So I thought maybe it will be useful for the state syllabus students, and that's why I'm doing this. Okay, so 12th classes actually I want to do, but I need to check it whether it is with me. Anyway, it won't be here, I guess. Let me check. If I'm getting, I'll do for that also. Okay, and all the chapters I'll be doing, especially laws of motion. One reason is there because one subscriber asked me, Honey George, I don't know whether it is her parents' name or is her name, I don't know. She asked me, can you do that revision for laws of motion? Surely I'll do. I'm planning to do for all the chapters if the time permits. That's all. Okay, so don't worry about it. I'll be doing a quick revision also relating that laws of motion chapter, and I know the CBSE and state syllabus little bit different because some of the topics are more there in the state syllabus, that is Wien's displacement law, like that, and all many questions children asked, but I'll try. Okay, while I'm getting the proper material, I'll just do a video relating to that also. Now I am concentrating on this previous year question paper pattern. Okay, so we'll start. Next question is, state in the following cases whether the motion is 1, 2 or 3 dimensions. A butterfly flying around a flower. Okay, a butterfly flying around a flower is, it's a 3-dimensional motion. An object which is moving through air will be a 3-dimensional motion. A bus moving along a long and straight rod, that a straight rod, it is 1-dimensional motion. Derive the equation of motion for non-uniform in 1 dimension. Okay, for non-uniform motion, if it is under non-uniform motion, how we will be deriving the equations for non-uniform motion? If it is in non-uniform motion, then only velocity will be changing. Okay, don't get upset while saying the question. If it is under non-uniform motion, then only velocity will be changing. If velocity is changing, then only acceleration will happen. So we will consider the object is under uniform acceleration and will be, so v is equal to u plus at, v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square equals 2as. So these formulas you should derive using graphical method. The method it didn't mention properly over here, so you can use the graphical method. Next, look at the graphs in figure A carefully and state which of these can't represent 1-dimensional motion with reason. So the graphs are given like this. This is time and this is displacement. Okay, so here one graph is like this, and another graph is here, this is time and this is displacement. Okay, so displacement time graph, here it is given like this. So tell me which of the following graphs is not representing 1-dimensional motion. So tell me at the same time, see, this time interval, the object is here also and the object is here also. At the same position, whether it is possible, at the same time, it's not possible. The same way here also. See, if I am considering this time interval, okay, the object will be here also, at the same time it will be here also. If I am considering this time, the object will be here also and the object will be here also. Okay, at the same time, the same object won't be there in different positions. So this can't be represented as a motion of 1-dimensional motion. Okay, so next question is find whether the given vectors are parallel or not. Okay, whether it is a parallel vector or not, how we can find out. Okay, here the vectors are given as A equals 2i plus 3j plus 4k and B equals 4i plus 6j plus 8k. Are they parallel or not? How we can find out whether it is a parallel or not? See, we know it is, if we are finding out A dot B, it is AB cos theta. If theta is equal to 0, okay, then A dot B will be equal to AB. Right. So if we are finding out this cos theta parallel means it will be theta will be equal to 0, or we can find out A cross B. While we are finding out A cross B is AB sin theta. AB sin theta. So sin 0 is 0. If the angle between A and B is 0, then we can say both will be parallel to each other. So while finding out A cross B, if it is the value is equal to 0, then we can say the given vectors are parallel. So here which one is more good way to find out the answer? I think this will be the more good way, A cross B, because AB you can find out, but you can find out the magnitude of A and magnitude of B and A dot B. That both the methods I will show you. Okay. First we will find out A cross B. How we will be finding out A cross B? I, J, K. Okay. Then A vector you can write down respective coefficients of I, J and K you will write down here. Okay. 3 and 4. So B, here it is 4, 6, 8. Here how we will be doing? First I into. While we are considering I, you can avoid this column and this row. The rest of the numbers are 3, 4 and 6, 8. While you are avoiding this column and this row, then 3, 4, 6, 8. So multiply these two. 8 3s are 24 minus 6 4s are 24. Okay. Next alternate positive negative. This is minus j into. So while we are doing this, you can avoid this and this column. So the rest of the numbers are 2, 4 and 6, 8. So multiply these two. 2 8s are 16 minus 16 plus k. Next is positive. So you can avoid this column and this row and this column. So here it has 2 6 are 12, 4 3s are 12. So 12 minus 12. So 24 minus 24, 16 minus 16, 12 minus 12. You will get it as 0. Why we are considering A cross B? As I told you, A cross B equals AB sin theta. If theta equal, if A and B are parallel, if A and B are parallel, theta will be equal to 0. Okay, that means theta is equal to sin 0, 0. Theta is 0. Okay, then if theta is 0, sin 0, A cross B you will be getting it as 0. Here we got the A cross B as 0. So it is easy. So otherwise what you should do? A dot B you should find out. AB cos theta. Cos AB, if theta equals 0, cos 0 is 1. A dot B will be equal to AB you will get. What you should do? You should find out the modulus of A, magnitude of A you should find out. How you can find out the magnitude of A? Root of A square plus 4 plus B square plus C square. So you will be getting it as root 29. Next is this root, the modulus of A and modulus of B you should find out. Okay, modulus of B will be equal to root of 16 plus 36 plus 64. Okay, while you are finding out this one, A dot B equals AB cos theta. Cos 0 is 1, so A dot B will be equal to AB. So how we can find out? Here it is root 29 into root 10, 10, 16, then 5, 11. Okay, this much we will be getting. Next, what you should do? A dot B. A dot B means 8 plus 18 plus 24. 8 plus 18 plus 24. That one you should find out. Whether both are equal or not, you should find out in that way. Okay, that is a little bit difficult way only. Better than that, you can opt for this option. That is, if both the vectors are parallel, we need to find out means you can take A cross B. If A cross B is equal to 0, the given vectors are parallel. If the given vectors are perpendicular, A dot B will be equal to 0. Okay, if they are perpendicular vectors, A dot B equals 0. If they are parallel vectors, A cross B equals 0. In that way you can choose. Okay, so the next one, what are orthogonal unit vectors? Orthogonal unit vectors means perpendicular unit vectors x, y, z. Okay, through those axes, that is vector I, vector j and vector k. These are orthogonal unit vectors. Orthogonal means 90 degree. Okay, so I and j are 90 degree with each other and unit vector also. J and k are 90 degree, so it is unit vector also. Okay, so they are orthogonal unit vectors. Next is, what is zero vector? Vector whose magnitude is 0 is called a zero vector. A vector whose magnitude is 0 is called a zero vector. Give its significance in physics with an example. Okay, see, if we need to see A vector A plus 0 vector will be equal to vector A. If I am adding a vector and its opposite vector, we will be getting a vector 0, because two vectors, while we are adding or subtracting, we will be getting a vector quantity only. How we will be representing that vector quantity? As a zero vector. Okay, clear? So these are the importance of zero vector in our physics. Okay, so or zero vector into A, it will be A, or zero vector into A will be equal to a vector 0. Okay, like that we can represent. This is the importance of zero vector. Okay, clear? Next question is, ceiling of a long hall is 25 meter. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall? So maximum height is given as 25 meter. Initial velocity is given as 40 meter per second. Okay, so what is the formula to find out the maximum height? H is equal to u square sine square theta divided by 2g. Right, so here 25 equals 40 square into sine square theta divided by 2g. 2 into 10 I am taking. Okay, so 50 into 10 divided by 1600. That is sine square theta. Okay, this is sine square theta. What we should find out? We should find out the maximum distance, r. Okay, maximum horizontal distance. What is the formula to find out the maximum horizontal distance? U square sine 2 theta divided by g. U square sine 2 theta divided by g. Okay, so if while you are finding out that u square sine 2 theta divided by u is given as 40 square sine 2 theta. So here the angle you will be getting, here there you can use your calculator, root of 5 by 60. Okay, how much you are getting? That one, 2 times that angle you should take and divided by 10. Okay, so you can find out the angle. First you should find out the angle from the maximum height. Then you can go for the range, R value. Okay, so the next one is, the figure shows the position time graph of a body moving along a straight line. Draw the velocity time graph of the body. See, the question is here. Figure shows the position time x and this is time. Here it is 5, here it is 15. Okay, here it is velocity and this is time, meter per second. Here it is in seconds. So here it is moving under with uniform motion. Since it is a straight line with a slanting position, it is under uniform motion. In uniform motion, it will be having uniform velocity. Velocity is uniform. That means velocity remains same. So till here velocity will remain same till 5 seconds, and then it is at a rest and it is decreasing. Here velocity position is decreasing, right? So it is negative velocity, again remains same till 15 seconds. From 15 seconds, next from 15 second it is till the final position is 20 second it is given. So 15 to 20, again it is remaining constant. Uniform motion. Then if the object is under uniform motion, it will be having uniform velocity. Uniform velocity means velocity remains constant. So you will be getting a straight line graph. Okay, clear? Then next is, from the graph, find the displacement in 20 seconds. What is the position time graph? How we can find out the displacement? So how we can find out the displacement? See, position, initial position is here and final position also the same point. So displacement will be equal to 0. Here displacement is equal to 0 because final position and initial position are same. Displacement. So here time only. So don't think it is different. No. The displacement means this is the position which they are representing. So initial position is here, final position is here, displacement is 0. Okay, the next one is, from the velocity time graph of a body moving with uniform acceleration, deduce the velocity time relation and the velocity displacement relation. So velocity displacement relation means v square minus u square equals 2as, and velocity time graph means v is equal to u plus at. Okay, in these two methods we can find out the velocity time relation. From the velocity time graph we can find out. Okay, so the next one is, when brakes are applied on a moving vehicle, it stops after traveling a distance. The distance is called stopping distance. Write an expression for stopping distance in terms of initial velocity u and retardation a. So a moving vehicle, it is moving with initial velocity, it was moving with initial velocity u and its acceleration, retardation is a. So retardation is given as a. How you will find out the stopping distance? How we can find out s is equal to ut plus half a t square. This is the formula to find out the stopping distance. Okay, or you can write it as v square minus u square equals 2as. That also you can, v square minus u square equals 2as. Since it is coming to rest position, v is equal to 0. So u square equals 2as and s is equal to u square divided by 2a. An object was moving with initial velocity and after some time if it is stopping, the time is not given. So better you can go for this option, u square equals 2as, because v is 0. Final velocity is equal to 0 over there. Okay, clear? Then next is, if the initial speed is doubled, keeping the retardation same, by how much will the stopping distance change? If the initial speed is doubled, so stopping distance s is equal to, here we got it as u square equals 2as. So s is equal to u square divided by 2a. If u is getting doubled, stopping distance will be 4 times, because u will become 2u the whole square it will be. So it is 4u square, 4 times the previous s. Okay, if initial velocity is getting doubled, so an object is moving with a particular velocity, initial velocity coming to stop, having a retardation. So it is given. Time is not given. If time is given, you could have used this formula, but time is not given, so better we can opt for v square minus u square equals 2as. Okay, final velocity is equal to 0. That means u square equals 2as. So s is equal to u square by 2a, and u is doubled means then 2u the whole square, so it is 4u square. So 4 times the initial velocity. Okay. So these are some of the questions from this chapter, and next day also I will be continuing with the same chapter only. Some more questions are there, so that one we will discuss, and after that we will be starting our next chapter, that is laws of motion, and that one after quick revision only I will continue. Okay, because it is a request from Honey. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.